Good afternoon or morning, PreCalc students, but just want to introduce you here to Chapter 5, Section 3, and where we are going to go next in pre-calculus. So we've spent the first half of Chapter 5 really focused in on our identities and verifying identities, and where we're going to go next is solving trig equations, all right? And so this is just going to be a little introduction video. So you get a little math work in over your 4-day break here this weekend, all right? So I'd encourage you to pull out your notebooks. Again, hopefully you have your headphones popped in, or maybe you're sitting at home. But take some notes, and then there'll be a short little homework assignment for you to complete at the end as well, all right? So here's where we want to begin, all right? If I asked you to solve sine of x is equal to 1/2, my question to you would be, what would you say to that? All right. Now, hopefully you would look at this problem and you would realize, hey, we've done something like this back in Chapter 4, right? We took trig functions like this and we utilized the unit circle. And so you might start thinking about your unit circle again, and you'd go, hey, I kind of know that sine does equal 1/2 in quadrants 1 and in quadrants 2, because it's positive there. And then you could think through those values and you go, hey, I know that sine equals 1/2 at pi over 6, right? And at 5 pi over 6, right? Those would be the two angles on the unit circle where sine of x equals 1/2, all right? And if you answered with those two things, you'd be on the right track, okay? But what we're going to do here in Chapter 5 is we're actually going to add a little bit to this, all right? Because those would not be all of the solutions where sine of x equals 1/2, right? Because hopefully we would recognize these are just the solutions in less than one rotation, right? But both of these angles have coterminal angles where they would also be equal to 1/2. All right, so we're going to take the unit circle and we are also going to connect it to the graph of the trig function, okay? So just to explain what you see on this graph here, right, we have our graph of our sine function, right? We just have the basic parent function, so you can see we got a starting point here at 0, 0. We're up 1, we're down 1 for an amplitude, and we have a period of 2 pi units, okay? So if I was just thinking about sketching a frame around this, here would be one cycle. Bear with me on my terrible box drawing, but I think you get the idea. There's one frame of the sine function, right? And that one frame of the sine function has pi over 6 and 5 pi over 6 as the solutions, okay? So this red dotted line here, this is representing where y is equal to 1/2, right? So we have our sine graph and we have 1/2. And we're looking at all of these points where they intersect, right? Well, every 2 pi units, these two solutions are going to repeat themselves, right? So if I add 2 pi to pi over 6, right, that's going to give me a whole nother angle where sine does equal 1/2. And if I add 2 pi to 5 over 6, to 5 pi over 6, again, we get a whole nother angle where sine is equal to 1/2. And we also get the same thing if we go to the left side, right? If we come over in this direction, right, if we subtract 2 pi from both of those angles, we also get coterminal angles where sine is equal to 1/2, all right? So what we're going to do as we work through these problems today is we are going to think about our unit circle, and we're also going to include the period to help us find what we are going to call the complete solution, okay? So let's take a look at some actual example problems, and let's put this together in practice, okay? So let's say that I wanted to solve sine of x plus the square root of 2 equal to a negative sine of x, okay? Now, I want to give you a couple of simple steps here to help you in this process, okay? So first off, we always want to isolate the trig function, okay? So in this case, we do have a linear problem. What that means is that I don't have any exponents on the trig function, okay? So what I'm going to do in this case is I'm just going to solve it like I would a normal algebraic equation. Think about Normally in a normal algebraic equation, we want to isolate the variable, but here we're going to isolate the trig function. So I want to get sine of x by itself, all right? So what I'm going to do here to start is I'm going to take and I'm going to add sine of x to both sides, all right? So if I take sine of x plus sine of x, all right, that's going to give me 2 sine of x. And then I have this plus square root of 2, and we're equal to 0 right now, right? So I've just taken this sine of x, and I've added it to the other side, all right? Now, again, our goal is to isolate the trig function. So now I'm going to take this square root of 2, I'm going to move that to the other side. So that's going to give me 2 sine of x is equal to a negative square root of 2 when I move that to the other side, all right? Now, again, my goal here is to isolate the sine of x. I want to get sine of x by itself. So now I'm going to take and divide both sides by 2, all right? And we just end up isolating that trig function, meaning I get sine of x by itself, and I end up with sine of x is equal to a negative square root of 2 over 2, all right? So now, just like on the previous problem, my thought process has to go back to my unit circle. And I'm going to have to think about, okay, what angles does sine equal a negative square root of 2 over 2? All right? So our unit circle knowledge from last chapter needs to stay with us, okay? Well, I know right off the bat when I see square root of 2 over 2 that that's a 45-degree reference angle, right? Or a pi over 4 reference angle, all right? Now, because sine is negative in this problem, that's got to happen in quadrants 3 and in quadrants 4, all right? So I'm going to have 2 solutions here to my problem. So I'm going to say, hey, x is equal to a negative square root of 2 over 2 for sine at 5 pi over 4 from the third quadrant, okay? And also 7 pi over 4. And that's going to be my fourth quadrant solution of where sine is equal to a negative square root of 2 over 2, okay? Now, again, these are just partial solutions. Those are just the solutions from one revolution around the unit circle, right? But we know that that graph of sine keeps going in infinite directions in both ways. So this is where the complete solution comes into play, right? So when we get down to this point, right, I have my primary solutions from the unit circle, all right? But now I'm going to add the period of this equation to this. So I'm going to say plus. Now I know that the period of my basic sine function is 2 pi. And then we're going to plug in an n, right? So n could be any number. So I could put 1 in for n, right? And that would give me 5 pi over 4 plus 2 pi. I could plug in a negative 1. That'd give me 5 pi over 4 minus 2 pi, right? And then we could keep adding on more rotations from the unit circle. So we could do the same thing down here, plus 2 pi n. All right, and these are my complete solution to this problem, okay? Now, hopefully as you look at that, you just recognize it's some pretty basic algebra to get started, right? Isolating the trig function. Then we're utilizing our unit circle to identify those primary solutions. And then we're utilizing what we know about the graph of sine to make the complete solution, okay? So let's try another one of those just for good measure here. So let's take this problem, all right? We have 4 cosine squared x minus 1 equals 2. So I'm going to treat this, again, pretty much just like I did my previous problem. I want to isolate my trig function, right? That's going to be important. Now, some of these other problems that are nonlinear and using the identity, we're going to see those on Monday. Or excuse me, on Tuesday when we gather back together. All right, but again, let's just treat this. I'm going to isolate my trig function. So the first thing I'm going to do is add 1 to both sides. So that's going to give me 4 cosine squared theta, or x, equals 3, right? Adding 1 to the other side, okay? Now I want to divide both sides by 4. So I'm going to go, hey, that's cosine squared of x equal to 3/4, okay? And now my next step, I want to isolate the trig function. I need to get rid of the squared. So I'm going to take the square root of both sides. All right, and when I take the square root of both sides, the square root of cosine squared is cosine of x equal to, now when I take the square root over here, right, the square root of 3, well, that's not a perfect square, so I'm going to leave that the square root of 3, right? The square root of 4 is 2, but then remember, anytime we take a square root, that's plus or minus, okay? Now, this is kind of an interesting situation, right? That then means that I'm really looking at all 4 quadrants in this problem, right? Because I'm looking where cosine is both positive square root of 3 over 2 and where it's a negative square root of 3 over 2, okay? So again, I just got to think through those reference angles. Okay, where is cosine in my unit circle equal to the square root of 3 over 2, right? Well, in the first quadrant, all right, cosine is the square root of 3 over 2 at pi over 6, or 30 degrees, okay? In the second quadrant, cosine is equal to, in this case, a negative square root of 3 over 2, right? But also the same reference angle, so it would be 5 pi over 6, just short of pi. In the third quadrant, right, cosine is a negative square root of 3 over 2 at 7 pi over 6. And in the fourth quadrant, cosine is positive square root of 3 over 2 at 11 pi over 6. Okay? And then again, I want to write the complete solution to this, right? So I'm going to say, hey, this is plus the period of cosine, which just like sine is 2 pi. So I'm going to go plus 2 pi n on all of these solutions, right? So if I take any of these angles and I add or subtract one or more than one rotation, I'm going to come up with an entirely different solution for this cosine function, but all of those would be equal to either a positive square root of 3 over 2 or a negative square root of 3 over 2, okay? So again, just like our previous problem, we were utilizing our unit circle to help us identify the angles where cosine meets the ratio, and then we're adding on that period. All right, so again, we're going to build off of this on Tuesday, but if you can get some basic understanding of working with trig equations, that's going to make our lives a lot easier on Tuesday. All right, so that is it. Short little homework assignment for you. And again, you're just going to be solving some basic trig equations today utilizing those unit circles, okay? Next week on Tuesday, we'll kind of take the next step with this. But I hope you guys have a great day, and I will see you all next week.